Hi everyone. This lesson we're going to discuss moles and molar masses. So if you follow in the textbook, you'll see the definitions they have for moles. So basically a mole is defined as a number of carbon-12 atoms in 12 grams of carbon-12. So by now you know that carbon has several different isotopes. We have carbon-12, carbon-13, carbon-14. And so in the periodic table it has an average mass of 12.01 grams per mole. But if we looked at just the carbon-12 isotope, then the mole would be defined as the number of carbon atoms that are in that 12 grams of carbon-12. And so that number turns out to be 6.0221 by 10 to the 23 atoms. And so it's really off this, this standard that all the molar masses are based upon. So if you look in your periodic table and you look up potassium, and it has a molar mass of 39.10 grams per mole, it means that in that 39.10 grams of potassium you would have this number of potassium atoms. So it's a convenient number to use, the mole. In the same way that you might buy a dozen bread rolls from a baker and they'd say a dozen instead of saying 12 or something, we say a mole instead of this big number here. And the reason we use such an odd number is because we define it from carbon-12. Okay, so let's have an example of magnesium. So magnesium has a molar mass of 24.31 grams per mole. And so if we look in the periodic table here, okay, it's a bit hard to see there. Let me get this one, it's easier to see. So if we look on the periodic table here, you can see that magnesium's in this second column, and it has a mass, a molar mass of 24.31 grams. Okay, so magnesium has that molar mass. Again, this means that if we have 1 mole of magnesium, then that's how much it would weigh. It would be the 24.31 grams. And so the mole means that it has 6.0221 by 10 to the 23 atoms of magnesium, which weighs 24.31 grams. We also call this the Avogadro's number, and so you'll often hear it referred to as Avogadro's number. We have this Na, which is the symbol we use for Avogadro's number, and so that's just how we define it. The masses given in the periodic table are molar masses, and so again, just as another example, the molar mass of calcium is 40.08 grams per mole, and this refers to the average mass of the isotope. So calcium has several isotopes, and so this isn't a nice neat number. And again, with the magnesium, it was 24.31 grams per mole. That would include all the different isotopes that magnesium has. So those decimal points, the reason they're not whole numbers is due to the effect of the relative abundance of the isotopes. How we like to use these, the masses and the molar masses, to calculate the number of moles, and we use this formula for that. So number of moles, N, equals the mass divided by the molar mass. So the easiest way to really show this is just to do a few examples. And so let's have a look at one example. How many moles in 15.2 grams of aluminium? Well, the number of moles would equal the mass over the molar mass, and so that would be 15.2 grams, because it's given in the question, divided by the molar mass, which is 26.98 grams. That molar mass comes from the periodic table. So if we look at the periodic table and we look at aluminium, we said it's 26.98 grams for the molar mass. What about if we have compounds? let's have a look at another example. How many moles are in 187 grams of calcium carbonate? What we have to do is we look at all the individual atoms in the molecule. So we have a calcium atom, we have a carbon atom, and we have 3 oxygen atoms. So the molar mass in this case, the capital M, is going to be the sum of the molar mass of the calcium, molar mass of the carbon, plus 3 times the molar mass of the oxygen. Okay. So we have from the periodic table 40.08 for the calcium, 12.01 for the carbon, and 3 times 16 for the oxygen. So that gives a total of 100.09 grams per mole. So the number of moles would be the 187 divided by the molar mass, which is 100.09. So this is a formula you'll have to really remember, is that N equals little m over big M. And so our answer comes out to 1.87 moles. If we have 13.7 moles of water, what is the mass? So this is a way of sort of manipulating that formula around a bit. But first of all, we need to know the molar mass of water. So the molar mass of water is going to be the molar mass of oxygen plus 2 times the molar mass of hydrogen, which is our 16, plus 2 times the molar mass of hydrogen, which is 1.0079 grams per mole, to give us a total of 18.02 grams per mole. This won't come out exactly 18.02, so leave that value on your calculator to avoid any round-off error, and then you'll be able to use that value in these subsequent calculations. So when we rearrange this N equals little m over big M formula, we get M equals little n times big M, which is number of moles times molar mass. So we put in our number of moles, which was 13.7, as given in the question up here, and then we multiply it by our molar mass, which we've left on the calculator, and we get this answer, 247 grams, to the right significant figures. And the other way we can rearrange the formula is if we use the formula to find the molar mass. So in this question we start out with 0.023 moles of a certain compound. We're not sure what that compound is, but we do know that when we weigh out a certain mass, we have 0.023 moles, and that mass that was weighed out was 1.3 grams. So what is the molar mass of the compound? So we start with our original expression, which is number of moles equals mass over molar mass, and then we rearrange that equation until we get it into the form that is molar mass equals mass over number of moles. And so you can see the steps that I've taken to get to that. So then I just put in my mass and I put in my number of moles, and that will give me 57 grams per mole. And so that would be the molar mass of whatever this compound happens to be. And so I'll just leave it there for that lesson. And if you look through the textbook as well as this video, you should have a pretty good basics of how the mole is and how we can relate that to mass and molar mass to work out number of moles.